Awesome. Okay, great. So hello from my screen. Last time we talked about for loops, we revised for loops, and we also introduced while loops. So now today we're going to be like distinguishing between for loops and while loops and seeing differences between each. And we're actually going to be solving two different questions using for loops and while loops, just so we can solidify our knowledge in both loops. And these questions are actually part of the practice questions. So I thought it would be nice to again together and perhaps start with the first one and start with solving it through or like by using a for loop. So we are going to try to find, so we are going to ask the user to enter n, and we are going to find 2 to the power of n using a for loop. Okay, so this was part of the extra practice questions, but I want us to solve them together because these are really, really fun questions and they can, so it would be nice to solve them together. Let's start with for loops first. So I want someone to volunteer and help me write a program from scratch that could help us find 2 to the power of n. Who would like to help me? I'm going to start with the first step. So what do you girls think? What would actually be before the for loop? Shouldn't we ask the user for something? Shouldn't we be asking the user to give us a value since we are finding 2 to the power of n? What do you think? What would be our first step?
First, we declare n.
We declare n. Perfect, exactly. So we first declare n.
And then cnn.
Perfect, okay. Third step, what do you think?
Okay, int I equal to 0.
Equal to 0, tamam. What else?
I less than or equal to n.
Okay.
And I plus plus.
I plus plus. Oh, let me know. Yes, tell me.
That's okay, continue.
I think I know what you're going to be telling me now. I just wanted to say that we should be storing our value somewhere, right? Shouldn't we be storing the value to the power of n? Exactly. So we're going to have to be storing it somewhere. So I am going to declare a variable and call it mult, for example. But since we are going to be doing a multiplication process and I want to be giving mult an initial value, what do you think we should be giving mult? What should the initial value be? Assuming, for example, the user entered n as 0. So 2 to the power of 0 is 1, right? So we want to put into account all these different possibilities. So what do you think we should initially give mult? Like what should we initialize mult as?
1.
1. Perfect. So we're going to be giving mult, which is the variable we are going to be storing the result in, an initial value of 1, because we have to, again, put into account possibilities, assuming the user, for example, enters n as 0, 2 to the power of 0 is 1. It's not 0. So we are giving mult an initial value of 1. And now we're starting with the tricky part. So how exactly can we use this loop to find 2 to the power of n? What do you think? I'm going to give you the first step. Since we're storing the value in mult, what do you think? So the for loop is supposedly going to help us multiply mult by 2 n times. So if it was 2 to the power of 2, it's going to multiply 2 by 2 twice. So mult is going to be 1 times 2 times 2, which would give us 4. And so on and so forth. So how are we going to be multiplying mult? Or how are we going to be using mult to find 2 to the power of n? What do you think?
It's equal to mult times 2.
So mult equals
Mult.
Mult, okay, perfect. I thought you said 1 times 2. I was like,
No.
yeah, but mult is perfect. Mult times 2. Awesome, great. So here's the thing. Also, this is equal to mult times equals 2. It's the same thing. So, but the second one is just a shortcut. So basically, what Yasmin just said is that we are going to be using mult to multiply by 2 n times, okay? So I want us to test the code, and I want us to see if there's something else we need to fix. So of course we have to see out mult, right? Since we want to give the answer to the user. So let's first start by giving n a value of 3. 2 to the power of 3 is 8. So it's supposed to give us 8. So I am going to insert 3, and it's going to give us 16. So why do you think it gave us 16?
I should be less than or than n, not equal.
It should be less, exactly. Or we can say I equals 1. It doesn't matter. But exactly, because when we say less than or equal to n, it is multiplying mult by 2 one extra time, giving us wrong results. So that's why you always have to test your code and see. So let's try it again with the same n and see what it gives us. Since now, instead of repeating 3 times, it's gonna, instead of repeating n plus 1 times, it's gonna repeat n times. So when I equals 0, mult is gonna equal to mult times 2, which is 2. And then when I equals 1, it's gonna be 2 equals 2 times 2, which is 4. And when I equals 2, which is the last one, since we are only allowed to be less, since I is only allowed to be less than n, which is 3 in this case, it would multiply 4 by 2, which would then give us 8. So this is, it might be a little tricky, but I want us to actually try to translate this for loop and try to create a while loop instead. And I want someone other than Yasmin to help me. What do you think? I want us to remove this, okay? There might be some extra steps. I want us to replace it with a while loop. Any suggestions? What do you think? So with a while loop, I prefer for loops because they're a lot more compact. And last time, if you remember, we forgot the increment. So it went on an infinite while loop, which is something we always want to avoid. So basically with a while loop, there are extra steps, but sometimes a while loop can help you achieve something that would be a little difficult with a for loop. But I just want us to repeat the same exact question, which is 2 to the power of n, using a while loop. What do you think? What would be our first step? Girls, we talked about this so many times, but that's fine. Sometimes we tend to forget, and that's fine. I'm going to start with the first step, and I'm going to declare integer index. Okay? And what did we give the index variable, or what did we give I an initial value of last time in our for loop? We gave I an initial value of 0, right? So we are going to give index a value of 0, and index here is going to act as the integer I in the for loop that we previously wrote. And now I want you girls to help me. I'm done giving you hints. I want you girls to help me write this. What do you think? What would be our first step? What do you think? It's the same exact thing. Does anyone have any ideas? Anyone? I'm going to give you an extra hint, although I promise not to give any hints. And that would be to increase the index. So a while loop will keep on going until the condition over here, which we will be writing, is false. So there's a condition over here that we need to write that would help us find 2 to the power of n. However, the mechanism is the same exact thing. It's basically mult equals mult times 2. And we increase the index every time. But what was the condition in the for loop? Does anyone remember? How did we set the range? How did we set the condition in the for loop? Yes, Zaha. Did you have anything you wanted to add? I can't really hear you, so I'm not sure. Zaha, if you want, you can use the chat because I can't really hear you. Okay, so what do you think we should use for the condition? We are multiplying mult by 2 n times. Okay, let's check the chat. We said that I is less than n. Exactly, excellent. So I is less than n. Index, since we called our I here index, we are going to say index is less than n. Perfect, excellent, Zaha. So it's the same exact thing, just with a couple of extra steps. So in a for loop, we only needed 2 lines of code. Using a while loop, we needed 4 lines of code since we had to declare another variable called index. So this is the same exact thing. All we need to do is set our condition just like we set it in the for loop, and we set it as index is less than n. We multiplied mult by 2, which we gave an initial value of 1, since we can't give mult an initial value of 0, or else the result would be 0. So we gave it an initial value of 1, and we increased the index until the index was less than n, which would then give us the result of 2 to the power of n. I'm going to try to use 4, for example, and there you have it. It gives us 4. It gives us 2 to the power of 4, which is 16. I'm going to try something else. Let's try 5, for example. 32. Awesome. So our code is working. So now we could write 2 to the power of n. We could write a program that could find 2 to the power of n using a for loop and a while loop. So simply a for loop, all we had to do is use 2 lines of code. And with a while loop, we had to add a bunch of extra stuff. But it's important to know and to distinguish between both the loops. So I want us to actually try to solve the factorial. Okay, now factorial might be, and I'm going to delete all of this because I want you to help me write it from scratch. Factorial is basically, for example, when we say 5 factorial is given as an exclamation mark. 5 factorial is basically 5 times 4 times 3 times 2 times 1, which is 120. And 4 factorial is 4 times 3 times 2 times 1, and so on and so forth. And 3 factorial is 3 times 2 times 1, which is 6. So this might be a tricky one, but I'm pretty sure it's very, very similar. It's very similar to the 2 to the power of n example. And I want us to try to write a program that would help us find the factorial of a number using while loops and a for loop. So let's start with the for loop, just like we did before. And I want you to help me from scratch and use the chat if you need to. Don't worry about it. So what do you think our first step always is, since we're asking the user for n? So our first step is to declare n and ask for n from the user. So we're using for loops. Now I want you to help me. What do you think? Should we declare another variable? That's another hint. Should we declare another variable just like we did in the 2 to the power of n example?
Yes, in order to store the answer. So end factorial.
Exactly. You can call it factorial or fact. Sure. Yeah. And what do you think we should give the? What do you think we should give it as an initial value?
1.
Perfect. 1. Since here we are multiplying again, and we can't, if we multiply a value by 0, regardless of any other values we are multiplying after it, it's always going to be 0, which means our whole entire solution is incorrect. So perfect. Excellent, Yasmin. How do we find the factorial now? The for loop. This is the tricky part. Let's start with integer I. What do you think?
I equals 1. Can you hear me now?
Very similar. It's very similar. Yeah, Zaha, sorry. Can you say that again?
I'm just making sure that everyone can hear me so that I can say.
Yes, we can hear you perfectly.
No, I equals 1.
I equals, okay, sure. Awesome. And then?
I is less than or equal to n.
Perfect. Okay.
I
And?
plus plus.
Excellent, Zaha. Absolutely. So, factorial. Very similar to the 2 to the power of n example. What do you think? What do you think? It's a little trickier because last time we had a constant, which was 2, but now we are multiplying by something else every time. What is that something else? What do you think? I'm going to give you a hint. It's something over here.
Is it I?
Yes, absolutely. It's I. Since we're multiplying, so for example, when we go with 5 factorial, we are multiplying 5 by 4 by 3 by 2 by 1. And I goes from 1 to n. And that's why here we had to include less than or equal to n. So perfect, excellent. So fact equals, since we declared our variable as fact times I. Absolutely. Here it's basically in reverse, but it's the same exact thing. We are multiplying 1 by 2 by 3 by 4 by 5. It's the same exact thing. And then the last thing would be to see out the variable we stored the result in. Does that make sense? Do you have any questions before we test our code? Okay, I'm going to run our code and I'm going to try to see in 4. Awesome, 24. Let's try a bigger number. Let's try 5. 120 and so on and so forth. And if we go with 6, 120 times 6, which is 720. So this is basically how we can use for loops and while loops to find many different and various different mathematical, let's say, equations, or if we can find exponential functions, if we can find absolutely anything, if we want to find indices, and so on and so forth. So we can use for various different mathematical purposes, let's say. And now to the tricky part. Before we solve the last while loop question, I want you to help me write the same exact factorial code, but using a while loop. So what do you think? Who can help me with that? The same exact thing, just using a while loop. I'm going to remove all the, actually, I'm going to keep Cout fact. And I want you to help me. What do you think?
We first declare index equal to 1.
Absolutely, okay.
Okay, while while index is less than or equal to n.
Perfect, okay.
Okay, fact
Yes.
equal to fact times I.
It's I?
Index, I mean.
Index, perfect. Awesome. So, yeah.
Index plus plus.
Index plus plus, awesome. So this is basically it. Again, the while loop took a little longer. It took a couple more lines of code, but we made it work. So this is basically how we switch from a while loop to a for loop. But with the while loop, you always have to remember, you don't always necessarily need to declare an index variable. But for these examples, index variables or any variables, you don't necessarily need to call them index, really help you and ease the process of finding the solution. So let's just give this and let's just run this one last time and see if it functions the same way as it does with the for loop. Try again. So factorial of 5 factorial is 120, 4 factorial is 24, and so on and so forth. Perfect. So we attempted 2 to the power of n and factorial using for loops and while loops. So I think we should head to something a little more difficult and try to solve a CodeForces question that's actually very, very fun. But there are small little details that we need to pay attention to in order for us to be able to solve the question. So the question is called Bear and Big Brother. So we're going to read it together. Bear Limak wants to become the largest of bears, or at least become larger than his brother Bob. Right now, Limak and Bob weigh A and B respectively. So Limak weighs A and Bob weighs B. It's guaranteed that Limak's weight is smaller than or equal to his brother's weight. Limak eats a lot and his weight is tripled after every year, while Bob's weight is doubled after every year. So the question asks us, how many full years will Limak become strictly larger or like strictly heavier than his brother Bob? So we have Limak and Bob and they're bear brothers, and Limak wants to become strictly than his brother Bob. And one important detail that we need to pay attention to is Limak's weight is tripled after every year, while Bob's weight is doubled after every year. And it's guaranteed that Limak's weight is smaller or equal than his brother's weight. So here we have the test cases. Basically, the input is A and B. A is Limak's weight and B is Bob's weight. The output includes just one single integer, and that integer number denotes the number of years in which Limak will become strictly larger than Bob. Okay? So, oh, and by the way, off topic, we can also use the GDB compiler for text input, just like we always use with ID1. But I always want us to try to experiment and try different compilers, but you can use GDB because also just let me show you real fast. If we open GDB, which is the one we always use, which is this one, and we go to text over here, we can actually insert the text and use the compiler for whatever we need, whether text or interactive console, which is what we usually use when we use GDB. But regardless, I always want us to try to use different compilers. So I want us to try to solve this question using ID1. Okay, so quick synopsis. Basically, Limac, which is the first integer here, this is his weight, and he wants to become strictly larger, strictly heavier than his brother Bob. And these are the test cases, and we will be testing all of them to see if our code works. So what do you think our first step would be? I'm going to remove this. What do you think?
Declaring A and B.
Absolutely. So we declare A and we declare B. And then we have to ask for A and B, right? So we C in A and we C in B. And you can also C in A and C in B onto the separate lines, but this is just a little more convenient. Okay, awesome. So what would be our next step? What would be our second step? There's also something we need to store, right? Which is denoting the integer number of years after which Limac will become strictly larger than Bob. So what do you think? We have to store it somewhere, right? So I'm gonna go with year. I'm gonna store years. I'm gonna store the number of years which we will be printing out in a variable called years. Okay, and now it's your turn. How are we, this is a tricky question by the way, but we're gonna solve it together. So how can we figure out the number of years which Limac will be strictly larger than Bob? What do you think? What should we be using? It's something, but the trick here is knowing which specific thing we need to use in C++ to be able to find that question, to be able to find the result. What do you think? Okay, so let's go back to the question and read it. Well, not maybe read it again, but let's talk about it again. So basically, what we have to figure out is the number of years in which Limac will be strictly heavier than Bob. So let's trace this and let's do some math. So now Limac's weight in the first test case was 4, assuming kilograms, assuming any unit you want to use. And his brother Bob's weight is 7 kilograms. So in order for Limac to weigh strictly heavier than Bob, and since Limac's weight is tripled after every year, we have to triple 4 and double 7, since Bob's weight doubles every year. So 4 times 3 is 12, and 7 times 2, since it's doubled, is 14. Is 12 strictly greater than 14? Is 12 greater than 14?
No.
No, right? So does that mean that Limac got to his goal? No, because Limac's weight and Limac's goal is to be strictly larger than Bob. So not less than or equal to Bob's weight, but strictly heavier than Bob's weight. So we try again. So in the second year, Limac's weight tripled. So 12 times 3 is 36, and Bob's weight doubled. So 14 times 2 is 28. So I think things are changing around here. Is 36 greater than 28? Yes, right? Because
Yeah.
36 is obviously greater than 28, exactly. Which means that Limac will get strictly heavier than Bob in 2 years. Does that make sense? And if we go to the third case, for example, which is basically the easiest test case, Limac weighs 1 kilograms, assuming it's kilograms, and Bob weighs 1 kilograms as well. But since Limac's weight is tripled every year, in the first year, Limac's weight will be 3 kilograms. And in the first year, Bob's weight will be 2 kilograms, meaning Limac only needs 1 year to be strictly heavier than Bob. I hope this clears things out just so we can get back to the question and hopefully solve it. So what do you think? What do you think would be the first thing we should consider using?
A
while loop.
Perfect, absolutely. A while loop. So, what is the condition over here that would allow us to keep on entering the while loop?
While A is less than B.
Excellent, Zaha. Perfect. So while A is less than B, so A here is Limac's weight and B here is Bob's weight, enter the while loop. Awesome. So what's our next step? What do you think?
Maybe you should multiply A by 3.
100%. We multiply A by 3. And what about B?
By 2.
By 2, excellent. Okay, so when we multiply A by 3 and B by 2, does that mean Limac got to his goal? To his goal weight, which is to be strictly larger than Bob? There's an extra step that we need to do.
We should add a year. So year plus.
We should add a year. Absolutely, excellent. So we should add a year, meaning we are using year here, or years technically, because I called it years, as a counter. And what did we say about counters? You remember we said that we should always be giving counters initial values just so we can disregard any errors or garbage values. So what do you think we should give years here? Should we just leave it as it is or give it an initial value?
Equals to
What do you
0.
think? Equals to 0, exactly. We're always supposed to be giving these counters initial values. So we are starting with 0 years, okay? And as long as A is less than B, Limac will need another year, and then we would check again whether Limac is strictly larger or strictly heavier than Bob. Okay, so as long as Limac's weight is less than or equal to Bob's weight, then we will have to wait another year to see. Awesome, perfect. So what should we be telling the user? What is the question asking us to see out?
The number of years.
Number of years, exactly. So we see out years. Awesome, perfect. So all we did was declare 2 variables, A and B. A is Limac's weight, initial weight, and B is Bob's initial weight. And we set our years, which here acts as a counter, and we talked about counters previously. And as long as Limac's weight is less than or equal to Bob's weight, we have to enter the for loop, triple Limac's weight, double Bob's weight, and increase the number of years by 1. So plus plus is years plus 1. It's just a more convenient way. Awesome, this is great. So let's try all the inputs before we actually submit our code. I'm going to try the first input, which is 4 and 7, and it's supposed to give us 2 years. So let's see. Awesome, it gave us 2 years, and that's because it's going to need 2 years for Limac to be strictly larger than Bob. So let's try Let's try the second. Let's try the second test case. Oops, sorry. Okay, copy over here. All we have to do is and write the code again, write the test case again. Let's see, so it's supposed to give us 3 years. Interesting. Interesting. It gave us 2 years. Why do you think that is? There's something we forgot. What do you think? It's one tiny detail. Just one tiny detail.
Less than or equal to be?
Exactly, 100%. Because here, and I kept on repeating it because they stressed it over here as well, Limak has to be strictly heavier than Bob, meaning they cannot be the same weight, and Limak cannot, his weight cannot be less than Bob and cannot be equal to Bob's weight. Meaning, we will only enter the while loop if Limak's weight is less than or equal to B. Excellent, Zaha. So let's see what the while loop would give us now. Let's see what the compiler would give us now. Perfect. So it gave us 3 years because now at some point, Limak's weight will be equal to Bob's weight, which is something we do not want since we want them to be strictly heavier. So it will enter the while loop again and increase the number of years. And this is the last test case, which we already talked about. Let's see what it gives us. Awesome, so it gave us 1. So it's very important to test all of the test case provided because we tested the first test case and it gave us 2, right? However, like it gave us the right answer, but the code wasn't right because when it came to the second test case, we discovered that there was something wrong. Excellent, girls. So all we have to do now is try to copy our code and try to submit it through CodeForces and see whether they would accept our code or not. So let's see. Our code has been accepted. Awesome. So do you have any questions regarding Bear and Big Brother? It is a tricky question, but I'm glad we figured it out together. I'm honestly very, very happy we could solve this together that fast. That's great. So are there any questions regarding Bear and Big Brother before we move on to something else? Okay, awesome. So I think we're all good. Now I want us to, okay, so awesome. I think we have enough time to introduce a new topic and perhaps solve a couple of questions. So far, we talked about different data types. We talked about if statements, for loops, while loops, and these are all very, very important concepts in programming. But there's something that we will actually be using till the end of our course, which is arrays. Now, arrays are very, very important in all programming languages, not just C++, because they really help us ease the process while writing the code. So we talked about data types, we talked about different variables, and we talked about integers, characters, Boolean variables. We also talked about float and double, we talked about strings. But the thing about variables is that we can only store one single value in a single variable. So for example, if we have integer x, we can only give x a single value. We can only have one single quantity, which is 10 or 500 or 1000. And when we have a character data type, for example, we can only give it one character. If we have a string, we can only give it one string, and so on and so forth. And this is where arrays come in and help us figure out that inconvenience, let's say. So when it comes to arrays, think of arrays as if they are tables, or they're basically a table where we can store different values of the same data type in a single array. So when it comes to variables, we can only store one single value, but when it comes to arrays, we can store multiple values of the same data type. So for example, if I was again, the example I always like to go with, for example, if we are university professors or high school teachers, and we want to create a program that would help us store the grades of 5 students. Let's start simple. And let's go with float, for example. Okay, we can start with integer, we can start with float, we can do whatever we want. And let's call our array grades. So the first thing we have to do with, the first step would be to declare our array, declare the name of our array, and open and close 2 square brackets. And after that, we will open 2 curly brackets and give the number of values we need. So for example, we're going to start with small numbers. We're going to start with 5 different values. I'm going to give 78.9, for example, 56.7, 78, 90, and 67.9. So these are grades of 5 different students. All right. So when it comes to variables, as we mentioned, we can only store one variable. We can only store one value. But here, with the grades array, we could store 5 different values of the same data type. Okay, so this would be our first step. And the thing about arrays and the thing about C++ is that it is 0 indexed. So here we have 5 different variables. However, we talked about indexes before, and we just mentioned indexes now. The first value would have a 0 index, and the second value would have an index of 1. And the second would the third one would be 2, and the fourth one would be 3, and so on and so forth until we get to the last element. These values inside are called elements. And the thing about having a program that's 0 indexed is that we start with index 1 and we end with index size -1. So our size here is 5. We have 5 different elements, but the last index would be 4. So why would these indexes actually help us, and why do we have to know about the index? And that's because the index helps us access these specific elements in the arrays. So for example, if I wanted to print out the first element, which is 78.9, I would have to say cout grades, open and close square brackets, and write the index inside the square brackets. So as we mentioned, this is C++ is 0 indexed, which means 78.9 has the index of 0 since it's the first element. And of course, we end it with a semicolon. So basically, with the cout statement, all we're doing here is printing out the first element of the grades array. So let's run our code and see what the program gives us. It's supposed to give us 78.9. Awesome. So what if, and I want you guys to help me with this one, what if I wanted to print the third element in the array? What if I wanted to print 78? What should I be changing over here? What do you think? So in the square brackets, I want to include the index of the element I want to print. So if I wanted to print 78 and we start from 0, then the third element would have an index of, who can help me? 2, exactly. So always remember, we start with 0 index and we end with the size -1. So here, since we have 5 values, this value, which is the last value in the array, would have an index of 4 and not 5, okay? So let's try this out. Grades in between square brackets 2 is supposed to give us the third element of the array, which is 78. Awesome. And the cool thing about the arrays is that they act exactly like variables. For example, if I wanted to change the first element in the array, I do not want it to be 78.9. all I have to do is simply reassign it, but include the index I want to reassign. So if I wanted to change the first element, which has an index of 0 to 50, for example, that's all I have to do. And if I want to see it, I go with grades, same process, and include the index in square brackets after we name the array variable, after we name the array name. So all I did here was reassign the first element and give it a value of 50, and it took the changed or the altered value. Okay. For example, if I decided that I wanted more than 5 different grades, I wanted 10 grades, all I can do is set the number of grades. So for example, if I wanted 10, I would include 10 in between these square brackets. And I wanted to include 78 and 90. However, here we have 1, 2, 3, 4, 5, 6, 7. We have 7 elements, and 10 over here, we have 10 values. The array here can store 10 values. The thing about arrays is that if you do not fill the entirety of the array, the compiler will automatically just fill the rest of the values with zeros. So we're going to talk about this right now. We're going to talk about a couple of stuff before we get to that. But this is the basics of arrays. It's simply, I would like to think of it as a table that would hold different variables or like different values of the same data type within a single array. Okay, and always remember, we start with index 0 and we end with index size -1. So the last element here, for example, if we actually wanted to fill all of them, so this is 8, 9, and 10, this would be the last element. And the last element here would have a index of 9 and not 10, since we started with 0. Okay, so here we are working with very, very small values and very small numbers. What if I had 100 students and I wanted to store 100 grades? Would it be convenient to actually see out or see in or whatever 100 grades 100 times, like manually write the grades 100 times? And for example, if I wanted to change each and every grade, or if I wanted to print each and every grade, would it be convenient to say grades 0 equals whatever, and then grades 1 equals whatever, and so on and so forth? Would that be convenient? Absolutely not. That would not be convenient nor efficient. And there's something we actually talked about throughout our course that would help us with that. So what do you think? What do you think we can use that would help us access the elements in the arrays in a more convenient and efficient manner?
We can use an array, and we can use the indices instead of, assigning each value.
Exactly. So we have to access values of the arrays using the index of each and every element. But what if I wanted to print all of them? What if there were 100 grades? There's something that we took that would help us access each and every index without manually having to write them down and writing down 100 cout statements. There's something that we can use. What do you think that would be? What helps us with that? Something we talked about today.
A for loop.
Exactly, a for loop can help us with that. So I want to see out all these variables. I want to see out all these values. I want you to help me with that. What do you think? What do you think I should include here in the for loop? The same exact thing we used to do.
And I equal to 0.
Mm-hmm.
I is less than.
Perfect. Less than.
Length dot grades.
Okay, so we're gonna stick with 10 for now. We're gonna stick with constant values.
Okay.
So we're gonna go with less than 10. Exactly. Okay. And
I plus plus.
I plus plus. Awesome. This is great. So Yasmin, why did you decide to start from 0?
Because the index in the array, the first index is 0.
Absolutely. And we say less than because there's no index 10. The last index in the element and last index in the array would be 9. So we're going to go from 0 up to 9 and not up to 10, as it would give us an error and it wouldn't work properly. So as I mentioned, I want us to print the values of the grades inside the array right now. Who can help me with that? So C out less than, less than. What should I include over here? What do you think? So I want us to print the values. Close.
لا grade
Mm-hmm.
I.
So square
Inside
bracket.
Yeah.
Yeah, okay, awesome. So this is exactly how we do it. If I wanted to print the indices, yes, I would print I. But here, I want us to print the elements. I want us to print the values inside the array. So we include the array name, which we declared as grades. And inside the square brackets, we include I, which here acts as the index counter, let's say. So let's see what it gives us. It's supposed to give us 78.9, 56.7, 78, and so on and so forth, until we get to the last element. Perfect. So I want us to try to delete the last two values and see what the compiler gives us. It's not going to give us an error, but it is going to do something else. So as we mentioned, it would give us 0, 0. So if you did not fill in any other values, it would give us 0. Does that make sense? So basically, this is simply what arrays are all about. And we can use integers, we can use doubles, strings, we can use any data type we would like to use. Okay, and the thing about arrays is that, well, I wouldn't say most of the time, but in some cases, you would not know the contents of the array. Sometimes I would want the user to insert these values. So I can just simply create the array and give it an initial size and ask the user for the array values. Okay, so you don't always necessarily need to fill in your array or give your array initial values, but you always have to give your array an initial size. Okay, so today we're going to start with very simple questions. So we can actually start with, or like at least increase the difficulty next time. So we're going to start with very, very simple questions now. So what if I want to ask the user for the values of the array, and then I want to print them. I want to print them out, and that's it, just for now. So for now, I'm going to remove this for loop, and I want us to write it from scratch, and I'm going to go with 7 values, for example. We're going to start with constants now. So I want us to ask the user to input the grades, and then I want our program to print out these grades respectively and in order. What do you think? What would be my first step? I'm going to start with prompting the user. I'm going to go with please enter grades. Okay? And I want you to help me. What do you think? What would be my first step?
I need to store the grades somewhere.
Okay, so we're storing the grades in the array. Okay, but I need to ask the user for the grades, and I want to receive the grades, right? So how can I do that? There's something we just did that we have to repeat. What do you think? So yes, we are storing the values, but we want to store the values here in the grades array. So I'm going to start with a for loop, okay? And I want you to help me now. What What do you think?
And
Mhm.
0.
Awesome. And then?
I less than 7.
Mm-hmm.
I plus plus.
Absolutely. And then?
CM.
Yeah.
Greater than grades.
Mm-hmm. And then?
We open brackets I.
Perfect. Absolutely. So this is how we store the grades. And I'm using a for loop here because it's more convenient. Because now if I wanted to see in the grades 7 times, I have to write see in grades I 7 times, which is not efficient whatsoever. And now we're working with very small numbers now, but what if you had 20 or 50 or 100 or 1,000 elements? You can't just manually write down these statements. You have to use something that would help you with that, hence the for loop. Okay, awesome. And I also want us to print the grades. So what do you think? It's just an easy extra step. I want us to receive the grades first, and then I want us to print them all at once. What do you think? I'm gonna go with another for loop. Okay. I'm gonna actually copy this just so we can be a little more efficient. And there's something I need to change. What would that be? Very, very simple.
See out instead of seeing.
See out. Perfect, exactly. And of course, we have to change the arrows. So less than, and print out the grades. So I'm gonna, just so we can be a little more organized, I would see out the entered grades are, okay, and see what the compiler would give us. Let's give it a shot. So it's gonna ask us for the grades. I'm gonna just go with random numbers. Random numbers. Oh, I forgot the end line. It's fine. So basically, it printed out 67, 89, 34, 23, but they're all compact and like they're all next to each other because I unfortunately forgot the end line. So this is basically how arrays work. We ask the user for the grades. We are storing the grades in the grades element, which is of a float data type. And all we did was add another for loop and see out the grades. Okay, so I want us to try something else, and I want us to keep this for now, but I want us to find the sum and the average of the grades. So who can help me with that? I'm going to keep this just so we don't have to repeat it again. We're simply asking the user for the grades, okay? But I want us to find the sum and average. So, any ideas? What do you think? So who remembers how we used to find the sum with just normal variables? What did we used to do?
First, we need to declare sum. And sum.
Is it int? Do you think we should go with int?
No, float.
Float, perfect, yes.
Okay, sum equal to 0.
Awesome, okay. And we also want to find the average. So what do you think?
Also the same thing, float average equal to 0.
Equal to 0. So we can give it an initial value and we can leave it as it is. That's fine. Because average at the end of the day, we are going to be giving it the value. It doesn't really matter, but we can stick with that for now. So we are receiving the values from the user. So cn grades, and we are we are receiving them from index 0 to 6. But now we have to find the sum. So I'm going to remove this. And the biggest hint here is that we are going to be using this for loop. So how do we use the sum? How do you remember how we used to find the sum with normal variables? What did we used to do? What do you think? How do we find the sum?
Sum equals sum plus grade I.
Absolutely, perfect. Grades I. So here, the for loop is gonna add the grades all together, okay? And we are storing the grades here in the sum variable. And now all we have to do is see out the average. And that's the easiest part. What do you think? See out average of students, or like average of grades, equals, what do you think?
Average divided by 7. I mean sum divided by 7.
Sum divided by 7. I actually wanted us to put this in average, but now average is not very important. We can also say average equals sum divided by 7 and see out average, since we already have the we already declared the average, but it doesn't matter. Like we can just simply say sum divided by 7 to be more efficient. So I'm going to run this code and see how it goes. But so far, so good. All we did was ask the user for these values. Okay, we added all these values together, and then we divided them by their number, which is 7, which we initially declared over here. So it's gonna ask us, it's supposed to ask us to enter grades also. I'm just putting random numbers. Okay, so the average of grades is 59.2857. Okay, so this is a simple question. I think it's time to ask a tricky question. I don't think it's tricky. We did something like it, and like we did something very similar to it before. But I want to ask you, if I wanted to see in the grades, okay, and I want to go with 5, so it can be a little easier. But I want us to print the grades in reverse. Okay, I'm going to remove these. We don't need them anymore. So I want us to print the grades in reverse. So see out the grades in reverse. And I want you to help me with that. What do you think? How can I print them in reverse? It's a tricky one, but we did something very similar before. I'm going to start with a for loop.
We start with 5, so I equals 5.
Absolutely.
And then
yes.
Greater than 0.
Is greater than 0, and then
I minus.
Minus, absolutely. And then over here, we are cout. We are simply printing the grades. So all we have to do is grades, I and L. Perfect, excellent. So in order for us to print the grades in reverse, all we have to do is simply reverse the index in the for loop. So we started from 5, which we declared here as the size of the grades array, and we ended at 0. Oh, but there's something actually we need to consider here. But let's try to run our code and see what we can do here. So it's going to ask us for the grades again. It's going to ask us for 5 grades now. So there's something wrong. there's something that we did wrong over here. So what do you think that would be? Because if we did it correctly, it wouldn't print this very, very random number. There's something over here in the for loop. So where do we start the index?
4.
We should start from 4, right? And what about the I?
It's greater than or equal.
Greater than or equal. So I actually wanted us to try I equals 5 and greater than 0, just so we can get the hang of it and understand that there is no 5 index, okay? We can't, in the array, we always start from 0 and end at size -1. So I wanted us to actually do this question just so we can always remember that there is no size index. We're going to start from 4. If we want to print from reverse, we start from size -1 and end at 0. A great job. So let's try to input again. Let's try to input the numbers again. See what it gives us. Perfect. So it's fixed. It was 78, 90, 67, 56, 45, and now it gave us the array in reverse. So one last question I want us to solve, and then I'm going to give you a break since we've been solving questions all day. And this is a very, very simple question. It's very simple to the things that we used to do. So I'm going to go with an integer array this time. And I'm going to go with integer age for ages. And I am going to go with 5. I'm going to give it a size of 5. And I'm going to ask the user for the ages. However, here, I want us to see out. Okay, I want us to find the number of individuals that are younger than 50. Okay, and I want us to find the number of individuals that are older than 50. And I want us to find the number of individuals that are 50 years old. Okay? It seems like a long question, but it's something that we did many, many, many times. But we're going to have to incorporate different concepts to be able to find that. Okay? And I think 5 is too little, so I'm going to go with 10. Although it's going to ask us for 10 variables, but that's fine. 10 values. So what would be my first step? I'm going to ask for the ages from the user. So what do you think? We're repeating the steps. How do we ask the ages from the user?
Using a for loop.
For loop, okay. Integer I.
Equal to 0, I less than 10, I plus plus, and then Cn greater than grade I. Age, I mean.
Awesome. Okay, I think it's faster because I'm typing it down, but perfect. Awesome. So now it's time to find the number of individuals that are younger than 50, older than 50, and that are 50. So what would be our next step? Where are we supposed to store all these values? What do you think?
We need to declare 3 integers.
Okay.
The first one, in the first integer, we need to store how many individuals are younger. So we can call it
younger, for example.
And then older. And equal, maybe.
Yeah, equal. And we're giving them initial value of 0, since we're assuming right now that since we always initialize our counters. Okay, we're assuming right now that there are no younger, are no older, and there are no individuals that are equal to 50. So what would be our next step? So our next step is very simple. It's going to be integer I equals 0, I less than 10, and I plus plus. And now to the fun part. What do you think? How can we declare all of this information? How do we figure it out?
With an if statement.
Perfect. Okay, if
Ages I is less than 50.
Okay, what do we do in this case?
Younger plus plus.
Perfect, absolutely. And what about else if? What do we include here in the condition?
Same thing, but greater than 50.
Greater than that, greater than, perfect. And which counter should we increase?
Older.
Older, plus plus. And the last one, since they're either less than 50, greater than 50, or 50, we can just say else. Else equal plus plus. Awesome, excellent, girls. So I want to print all these values. I want to print younger, I want to print older, and I want to print equal. Where do I see out all these variables? Where should I print them out? Inside the for loop or outside the for loop? Where do you think I should print them out?
Outside.
Outside, exactly. So we can say C out, younger than 50, equal, and we say younger, and line. Same goes for the rest. I'm just gonna copy and change. Older than 50, older. And the last one would be equal to 50. And all we have to print out is equal. Okay, so this was a very simple example. It's a little longer, but all we did here was ask the user for the age. We can prompt them here, see out, مثلا. We can say, see out, please enter ages. Just for the sake of clarity, we enter the ages, we declared our counters. If the age is less than 50, younger plus plus, it means we have a younger individual. Greater than 50, older plus plus. Else, since they're either less than, equal to, or greater, we say equal plus plus. And we can also say else if ages equals 50, but it's unnecessary since we've covered all of the possibilities. So let's try it and see what the code gives us. So it's going to ask for the ages. I'm going to go with very random ages and see what it gives us. Oh, there we go. So there are 4 individuals that are younger than 50. We have 1, 2, 3, and 4. Older than 50. 1, 2, 3, and 4. And individuals that are equal to 50. 1 and 2. So 4 plus 4 plus 2 equals 10, which is the number of elements we have in the array. Awesome. So these are very, very simple questions that we're going to that we went through today. Just a quick introduction to arrays. However, prepare yourself because next time we're going to be delving into more difficult questions and delving into ways where we can use arrays in different situations and for different questions. But for now, I think we're good since we discussed so many questions and we solved so many questions. And I don't want to tire you girls too much. So thank you for today. It was absolutely amazing. I am going to stop sharing the screen.